8.4, this is day 1, so 2.4, day 1. So I'm putting it on here. There will be 2 separate assignments. At the end of day 1, there will be an assignment, and at the end of day 2, there'll be a separate assignment. So your objective on this one is to be able to graph functions and identify symmetry. And it's going to be more along the lines of identifying that symmetry. So for any point xy on a graph, if the point negative x, negative xy is also on the graph, that it has symmetry with respect to the y-axis. So this is a graph showing this one, and it's this point here. If you look at that point there, it's -2, 0. And if you look at this point here, it's +2, 0. Y value did not change at all, but the x value, all it did was change signs. This gives us symmetry with respect to the x-axis. So basically, y doesn't change, but your x does, symmetry to y. Okay, the next one, if you have xy is on the point, then x negative y is also on the point. We have more than one point that we can use on these ones. The easiest one probably here would be this one here, where we have 0, 2, and then down here we have 0, -2. Y value didn't change, the x value changed sign. I'm sorry, let me go backwards. X value didn't change, your y values changed signs. Now this is true, excuse me, this is true here also, where you have a point of -6, 4, and down here you have a point of -6, -4. So there's quite a few examples on this one. Here's another one. We got a sideways parabola. I'm going to grab this point here. Your x value is 4, so you got a point 4, 4, and down here you have a point of 4, -4. X value didn't change. It's just the fact that your y value got 2 in there, 2 different ones. And the last one is your symmetry. You change x and y to both -x and -y. This would give you symmetry to the origin. This is also considered a 180-degree rotation. There it is, 180-degree rotation. This one here, the simplest way is turn it upside down. And it should look the same. So this is one of the things you can do on this one. But we can also look at the points. Up here I have a point of 2, 8. And down here I have a point of -2, -8. Both sides changed. Numbers are exactly the same, signs changed. This one, if I look at this point here, I have a point of 3/2, +2, and down here a point of -3/2, -2. Everything's exactly the same, only thing happened was the sign change. So first thing that you have to be able to do is identify your symmetry just by looking at it. And again, if it looks like a mirror image over the y-axis, it's symmetric to the y-axis. If it looks like it was flipped over the x-axis, then it's symmetric to the x-axis. And if you can turn it upside down, symmetric to the origin. Anyways, it was flipped over the x and y. So of course we have algebra tests that we can do on these. So, you know, if you have a picture, those are really easy to look at, but what if they don't give you a picture? Then what? So there are tests. Tests for x-axis symmetry, replace y with -y. If you get the same equation, it's symmetric to the x-axis. Replace y, if you want to look for y-axis symmetry, replace x with -x. If you get the same value, or in this case we're looking for our equation, get the same equation, it's symmetric to the y-axis. And if you change both of them and you get the same equation, then it's symmetric to the origin. So let's look at a couple of examples on this. So we have this one here. So the first thing I'll do is x-axis. So I'm going to change x to -x. So this gives me 5y equals 7 times negative x. Okay, that doesn't look like negative x, so let's erase it and make it look like negative x. Negative x squared minus 2 times negative x. I get 5y equals 7x squared plus 2x. And this one fails. Right there. So let me try taking y and switching it to negative y. So I have 5 times negative y equals 7x squared minus 2x. So now I have negative 5y equals 7x squared minus 2x. And again, it failed because of this guy right here. So let's do both. xy, and I'm going to change it to negative x, negative y. So now I have 5 times negative y equals 7 times negative x squared minus 2 times negative x, which gives me negative 5y equals 7x squared plus 2x. And again, this one failed twice. It failed here, and it failed here. So this one has no symmetry. Now, I do want to point out too, I don't want you guys questioning this one here. 7 negative x, but I'm squaring the whole thing, including the negative x. So when I square it, the negative sign goes away. Okay, let's try this one. Change x to negative x. So I get y cubed equals 2 times negative x squared, which gives me y cubed equals 2x squared. That one's good. Negative x. My x is changed. My y stayed the same. So I have y-axis symmetry. But we're going to go ahead and check the other ones. So if I do y and change it to negative y, I get negative y cubed equals 2x squared. So I get negative y cubed equals 2x squared. And this one failed right here. And let's go ahead and do the x and y. So I'm going to take x and y and change them to x, negative y. So I have negative y cubed equals 2 times negative x squared gives me negative y cubed equals 2x squared. Again, it failed. The same place as it did last time. So this one only had the y-axis symmetry. So let's go ahead and highlight that. I mean, I suppose I can highlight the answer on the other one, even though I had none. Let's try one more. Actually, I think for the class purposes, we'll do one in class. So I will do this one in class, just so that you get the chance to see what's going on and you have a chance to answer questions, or should I say ask questions. All right, one more idea on these is even and odd functions. If it's symmetric with respect to the y-axis, it's an even function. Again, over the y-axis. If it's a mirror image, then you have an even function. You can also write it as f of x equals f of negative x. Since we've already done trig, I'm going to throw trig as an example. Cosine of x is equal to cosine of negative x. It doesn't matter which direction you go, you're going to get the same sign. 45 degrees, cosine is radical 2 over 2. Negative 45 degrees, cosine is still radical 2 over 2. So that's one of the things we get to use. An odd function is respect to the origin, so you can turn it upside down and it looks the same. Or we can go f of negative x is equal to negative f of x. You can pull the negative out. By the way, from trig, sine was an odd function. Sine of negative x equal negative sine of x. I can use that 45-degree angle again. Sine of negative x, that meant I went down 45 degrees. I would get negative radical 2 over 2. Or I can just do the 45 degrees, sine at 45, radical 2 over 2, and throw a negative sign on front. Either or. Cosine is even, sine is odd. Now, here's the main thing. Functions cannot be both even and odd, so once you check for even, if it's even, leave it alone, you're done. Most functions, however, are neither. So don't be surprised if you get a bunch of, you do 5 problems, they're all neithers. It's more likely to get one that's neither than to get odd or even. Okay, so let's do a couple examples. I've got 3. We're going to do 2 together on the video, and the third one we'll do in class. Okay, so the first one, you check for even first. So even means that f of x must equal f of negative x. So we're just plugging in negative x for all of our x's. So f of negative x would equal 7 times negative x cubed plus 4 times negative x minus 2, or negative 7x cubed minus 4x minus 2. And this is f of negative x, but it does not equal f of x, so it's not even. Let's check for odd. That means f of negative x must equal negative f of x. So negative f of x, you're just going to change all of the signs. So negative 7x cubed minus 4x plus 2. And it failed again. It does not equal f of negative x, which is this guy up here. And it fails at the 2. Negative 2 plus 2. Not odd. Therefore, it is neither. But notice we didn't get even, so we had to check for odd. So let's go ahead and highlight that answer. Okay, let's check another one. A little line through here so we don't get it mixed up. Even. Again, means f of x equals f of negative x. So you just plug it in negative x everywhere you see x. So f of negative x would equal negative x plus 1 over negative x, or negative x minus 1 over x, which does not equal f of x. So, not even. So let's check odd. Odd says that f of negative x would equal negative f of x. Well, keep in mind we already have f of negative x, he's right there. So negative f of x, just throw negative signs in front of each term, negative x minus 1 over x, which equals f of negative x. So this one is odd. And we're done. Let's highlight that answer. There we go, highlight that answer. Okay, And that leaves us with one problem, and we're going to hold off to that problem. We'll do that one in class. I can go ahead and give you the homework. That way, if you want to get a head start on it, there it is, 1 through 45 odd, starting on page 214. All right, and good luck.